So this problem starts off by talking about what this thing is here and how it's used to measure the blood pressure. And the blood pressure is related to the difference in height between the two columns of mercury. And then at the bottom it actually gets into the problem and it asks, it tells us the difference in mercury height, which is 0.120 meters, and that's going to be a normal systolic reading. It's asking us to find the gauge pressure in pascals of that. It gives us the density of mercury, which is 13.6 times 10 to the third, or 13,600, and it gives us the ambient pressure or atmospheric pressure of 1.01 times 10 to the fifth pascal. So the first thing we can do is set up our equation, which we're going to use the absolute pressure. It's going to be equal to the atmospheric pressure, or P0, plus the gravity times the height of our liquid times the density of our liquid. So we have P0, which was the atmospheric pressure, which is a known of 1.01 times 10 to the fifth pascal, plus our gravity, which is 9.8 meters per second squared, times our height of 0.120 meters, times the density of mercury, which was 13.6 times 10 to the third, or 13,600 kilograms per meters cubed. So we plug all these values in and solve, we end up getting an absolute pressure of 1.01 times 10 to the fifth plus 9.8 times 0.20 times 13,600. We end up getting an absolute pressure of 1.16936 times 10 to the fifth. Now this is the absolute pressure, and this will not give us the answer because it's asking for the gauge pressure here in pascals. So to find the gauge pressure, we're going to take the absolute pressure minus the atmospheric pressure. That's going to give us our gauge pressure. And so this is pretty much just the pressure without the atmospheric pressure included. So by doing that, we can take this value subtracted by this value, our absolute minus our atmospheric. We end up getting a final gauge pressure value of 1.60 times 10, or e to the fourth pascal.